Hello and welcome to this video lesson. In this video, we're going to focus on the general form of the equation of a straight line. So far, we've spoken about gradient-intercept form or slope-intercept form, and this is one of the most important and useful form of the equation of the line. As a refresher, the y is the y-coordinate, the x is the x-coordinates of all the points that lie on the line, m is the slope, and b is the y-intercept. So gradient, intercept, intercept, that's why it's called the gradient-intercept or slope-intercept form. Where the gradient-intercept form fails a little bit is when we get a vertical line. So when we have a vertical line, you can see that the slope is infinite or undefined. So our slope here will be undefined, and you're multiplying an undefined value by x. It kind of gets messy. And you can see that for a vertical line, we don't actually have a y-intercept because it doesn't actually touch the y-intercept unless it's lying right at the origin and it's going right on the y-axis, and that would mean it has infinite number of y-intercepts. So this form no longer can explain a vertical line. Another form of equation that we have is called the general form, or sometimes it's called the standard form, and it's often written as ax plus by is equal to c, sometimes written as ax plus by minus c is equal to 0, but we're going to stick with this form over here. So in this form, the a value over here can be a positive integer or 0. So a belongs to integers, and it is larger than or equal to 0. The b value could be an integer, including 0. It could be negative. It could be positive. And the c value also can be an integer. It could be positive. It could be negative. Or it could take value of 0. Note that in this set of equation, or in this form of equation, if you let the b value equal to 0, then or if you have it in this form where ax plus by is equal to 0, if the b value is 0, then you get ax, should have this as c instead, ax is equal to c, and you can see that x will equal to c over a. If you divide both sides by the a value over here, ax divided by a will be x, and c over divided by a is just c over a. And you can see that this form of the equation, we can actually explain a vertical line. For example, in this case, we have x is equal to 3, so x is equal to c over a. C here could be 3, a could be 1, c could be 6, a could be 2, c could be 9, a could be 3, and so on. Or c could be negative 3, and a could be negative 1 to kind of explain this line. So this equation allows us to also, this form of equation actually helps us show vertical lines as well as horizontal lines and all other type of lines. It is, however, not as useful as the gradient-intercept form for other forms of line because it doesn't really help us understand what the slope of the equation, or what the slope of the line is, or what the y-intercept is. Alright, we're going to be looking at how we can derive the general or standard form from the gradient-intercept form. So if you're given the gradient-intercept form such as this, how do we actually turn it into the general form? So the first step is to use our algebra skills to move everything which has x and y. So in this case, we have x and y, so we're going to try to move the x here to the left-hand side. So everything that has x and y needs to be on the left-hand side, because if you remember, the equation is ax plus by equals to c. So ax and by need to be on the left-hand side, and the constant, which doesn't have the x and y, needs to be on the right-hand side. So we need to use our algebra skills to do that first, and then we need to use algebra skills again to change the a value to a positive integer and the b and c value to just an integer. And we'll go through 3 different examples just to give you an idea of how we can do this. We're going to start off with our first example, which says to derive the general form of the equation for y is equal to 3x minus 4. So our first step is to make sure that everything that has x and y are actually on the left-hand side of the equation, and everything else needs to be just on the right-hand side. So I'll solve this using blue. So our original is y is equal to 3x minus 4. To move the 3x to the left-hand side, I have to subtract both sides of the equation by 3x. And when I do that, I get negative 3x plus y is equal to negative 4. And when you move things, it's better to write the term that has the x on the left and the one that has the y on the right, because the form again is ax plus by is equal to c. Now we have to ensure that our a value is a positive integer and that our coefficient of y is an integer and our constant is also an integer. In this case, our a value is negative 3, so right away we can see that it's not a positive integer, so we need to make a change for that. We can see that our coefficient of y is positive 1. That's an integer, so that's fantastic. And the negative 4 here is also an integer. So all we need to do is make sure that this is actually a positive value and not a negative value. We do that by multiplying the whole equation by negative 1. We can do that by multiplying or dividing by negative 1. And if we multiply the left-hand side by negative 1, negative 1 times negative 3 gives us positive 3. So we get 3x. Negative 1 times y is negative y, so we get negative y. And multiplying the right-hand side by negative 1, we get negative 1 times negative 4, which is equal to positive 4. And I'm just going to write this in another way. Once we apply the negative multiplication by negative 1, just a step in between, we get negative 1 times negative 3x plus y is equal to negative 1 times negative 4. So we need to make sure that the negative 1 is being multiplied by the whole expression on the left-hand side and not just the 3x. It's one of the most common mistakes that students just multiply the negative 1 by the negative 3 here and they get the 3x. They forget to multiply it by the y, so they leave this as a positive y. They do multiply it by negative 4 and they get positive 4, and they get 3x plus y is equal to 4, which is not the correct solution. So you have to multiply the negative 1 by the whole expression here, which means that you have to actually apply the distributive property rule, and that means that you have to multiply the negative 1 by both of the terms on the left-hand side. So the steps that I would be looking for usually when I teach this the first time is to make sure that students know that everything is in the left-hand side and that this is the final answer is correct. So there's an accuracy mark over here, and there is a method mark for getting here, and I would actually put this both as an implied method mark, because using your algebra skills you might right away get to the final answer, so you don't actually need to show too many steps when it's a simpler question like this. Let's try 2 other questions. Now this one says derive the general form of the equations for y is equal to 1 over 3x minus 3. So we have to do the same steps. I'm going to start with blue. I have to make sure, actually I'll just write it down first, y is equal to 1 over 3x minus 3. I have to make sure that all my x and y's are on the left hand side. So to do that, I have to subtract 1 over 3x from both sides. So I am going to subtract 1 over 3x from both sides, and I get negative 1 over 3x plus y is equal to negative 3. Once I have this, I have to ensure that my a value here is a positive integer. It is not. My b value is positive integer, is positive 1, so sorry, it just needs to be an integer. It's positive 1, it is an integer, so that's correct. And this one is already an integer as well. In this case, this one is negative 1 over 3, so I have to get rid of the negative, and I have to get rid of the 3. So it's right now x is being divided by 3 or being multiplied by 1 over 3. So to remove the denominator 3 here, I have to multiply the whole thing by 3. So I can do this either in 2 steps or 1 step. I'll do it in 2 steps for this demonstration, but you can actually do this in 1 step. So I am going to multiply everything by 3 first. So 3 times negative 1 over 3 gives me negative 1x. Write the 1 for now. Plus 3 times y is 3y, and 3 times negative 3 is negative 9. Now, in this step, we can see that we have a negative integer here, and the a value needs to be a positive integer. So we multiply everything by negative 1. And we get negative 1 times negative 1 is positive 1. So I'll just leave that as x. Positive 3y times negative 1 is negative 3y. And negative 9 times negative 1 is positive 9. So this becomes x minus 3y is equal to 9. And that would be my final answer, because the coefficient of x is a positive integer, coefficient of y is an integer, negative 3, and my c value is an integer of 9. Now, to show your work for this one, I kind of want to see that you have applied the multiplication by 3 and the negative 1, and there's an implied method mark here. There is definitely a method mark here, something that I actually want to see at least one of these 2 steps, and I am going to leave one of them as an implied method mark and one of them as a method mark, and finally this one as an accuracy mark. So you can combine these 2 into one, so you can just say I am going to multiply by negative 3 right away, and then you will just get to this answer, and you don't actually have to go through all of these steps. Alright, we're going to do the last one. The last example for this section says to derive the general form of the equation for y is equal to 1 over, so I'll just write it down, y is equal to 1 over 7x plus 3 over 4. So again, we want to make sure that we have the x on the left hand side, so I will do that by subtracting negative 1 over 7x from both sides, and I get negative 1 over 7x plus y is equal to 3 over 4. Now I see that I have a negative integer over here. It needs to be a positive integer, so I need to make a change to that. I need to make sure that coefficient of this is an integer, and it is. And I need to make sure that the c value is an integer, which is not, as a fraction at the moment. So let's do this step by step, and then I'll show you how you can do it all in one step. So I have to get rid of the 7 in the denominator here, so I have to multiply the whole thing by 7. So multiply everything by 7, and I get 7 times negative 1 over 7 is negative 1. 7 times y is 7y. 7 times 3 over 4 is 21 over 4. I now have a negative integer here. I want to make it into a positive, so I will multiply by negative 1. So I get x minus 7y is equal to negative 21 over 4. And that means that I applied the negative 1 to here, made it a positive. Negative times positive is negative. Negative times a positive is negative. I now want to make sure that again, I have positive integer, correct. I have an integer, correct. I have a fraction. I have to change this to an integer by multiplying everything by 4. And when I multiply everything by 4, I get 4x. 4 times negative 7 is negative 28. And 4 times negative 21 over 4 is negative 21. All right, let's solve this using a second method here, and once you're much more comfortable with these questions, I actually expect you to use this method instead of going through all the procedure here. So here the first step is the same step. I do have to subtract negative 1 over 7x from both sides, so I will have to do this step and get negative 1 over 7x plus y is equal to 3 over 4. My next step here, I know that I need to get rid of this negative. I know that I need to get rid of the denominator 7 here, and I know that I need to get rid of the denominator of 4 here. So a common denominator between 7 and 4, well, actually, just to think about it more logically, I have to multiply it by negative 1. So I have to multiply it by negative 1. I have to multiply it also by 7 here to get rid of the 7 down here. So I have to also multiply it by 7. And I also have to multiply it by 4 to get rid of this 4 over here. So instead of writing all these in 3 different steps, I can simply multiply it by, here I have negative 1 times 7, which is negative 7, and negative 7 times 4, which is negative 28. So I can multiply the whole thing by negative 28, put this in brackets, and I will get to my final answer right away instead of actually going through all that procedure. So multiplying everything by negative 28, I get negative 28 over 7 here, or over negative 7, so that gives me positive 4x. Negative 28 multiplied by positive y gives me negative 28y. And negative 28 multiplied by 3 over 4 gives me negative 21. And you can see that we arrived to the exact same solution, just much less steps. There's nothing wrong with actually going through these steps over here, and obviously you will not get any marks deducted, but as you get more comfortable, it is recommended that you actually go through and combine everything together. And again, you don't have to. This is completely fine. In terms of showing your steps, an implied method mark, or could also be a method mark here, it's a little bit more involved in terms of the question and how many steps you need to do. You need to show at least one method here, and it could be just this method over here, or you can also, there's some implied method, at least 2 implied method of going through multiplying by 7, one multiplying by 4, and one multiplying it by negative 1, and an accuracy answer for this final step over here. So again, these are all methods. Actually, I'll put this as m, or just multiplying it by negative 28. Now, we talked about deriving the general form from gradient-intercept, so now we're just going to do the opposite. We're going to derive the gradient-intercept form from the general form. And we do this simply by looking at the general form and then rearranging for y. So let's do this example over here. It says to derive the gradient-intercept form of 2x minus 3y is equal to 12. So I'll just write down what the equation is first. 2x minus 3y is equal to 12. And now I want to rearrange for y. So the negative 3y over here, this is kind of the term that I'm trying to isolate. I'm just going to highlight that right now in green. So I need to isolate this first. It's being added by 2x at the moment, so we need to get rid of that. And we do this, I'll write it in different color, my steps here. I will subtract 2x from both sides, and I will get negative 3y is equal to 12 minus 2x, or simply negative 2x plus 12. There's no difference between how you write them. And then I can see that I am trying to isolate for y over here. Actually, I will highlight it in green. So to isolate for y, I can see that it's being multiplied by negative 3 because I have negative 3y, and that means it's y multiplied by negative 3. So to isolate for it, I have to divide both sides by negative 3. And I will do that actually. I'll write it in green over here. Divide by negative 3, divide by negative 3. And I get negative 3 divided by negative 3 cancels out, and I'm left with y. And on this side, I get negative 2x plus 12 over negative 3. Now, we can see that we have isolated for y over here, but it's still not nicely written in terms of mx plus b. So we do need to kind of separate this. So we know that this means it's negative 2x divided by negative 3 plus 12 divided by negative 3. So I will change the form to negative 2 over negative 3x plus 12 divided by negative 3, and write this in the most simplest form. Negative divided by negative gives me a positive, so I can leave this as 2 over 3x, and I have 12 divided by negative 3, which is negative 4. So instead of writing plus negative 4, I will just write it as minus 4. So now my equation is in the form of y is equal to mx plus b, where my slope is 2 over 3 and my y-intercept is negative 4, or the coordinate system of my y-intercept is 0 and negative 4. So this here is your final answer. And in terms of steps, we're looking to make sure that you know how to rearrange for y. So there is a method mark really to kind of do this. There's a method mark here, and there's an implied method mark, and you need to be able to show your answer in the form mx plus b. So here y is equal to mx plus b, and this would be an accuracy mark to leave your answer like this. We don't actually want you to leave your answer like this, even though this is a correct way of rearranging for y, but you do need to make sure that your right hand side is in the form of mx plus b. So I'll actually include that in the step here. Make sure that right hand side is in the form mx plus b. Let's do one final example for this lesson. This question tells us to determine the x and y intercept of this line over here, 4x minus 5, y is equal to negative 20, and sketch the function. So to determine the x-intercept, if we review from previous lessons, for x-intercept, we have to set our y value, or the y coordinate, to 0 and solve for x. And for the y-intercept, we need to set our our x coordinate to 0 and solve for y. So on the first one, our equation is 4x minus 5y is equal to negative 20. So 4x minus 5. Instead of our y value, I'm going to put in my y coordinate of 0 is equal to negative 20. Anything times 0 is 0, so this kind of cancels out, so you're left with 4x is equal to negative 20. You want to solve for x. X is being multiplied by 4 right now, so we divide both sides by 4, and we get x is equal to negative 5, meaning that our x-intercept is at coordinates of negative 5 and 0. Fantastic. So now we want to solve for our y-intercept. We're going to set the x-coordinate to equal to 0. So 4 times 0 minus 5 times y is equal to negative 20. And again, I'm just using this. The x value, 0, negative 5y is equal to negative 20. Anything times 0 is 0, so I'm left with negative 5y is equal to negative 20. I have to isolate for y, so I divide both sides by negative 5. And I get y is equal to negative 20 divided by negative 5 is 4. So then my y-intercept is, or has a coordinate of 0 and 4. Finally, I have to sketch the function. So to sketch, I will not have exact values, but I will try my best to have a nice x and y coordinate. Going to label x and y, and then I need to, well, I need at least 2 points, and I have the 2 points over here. I know that my x-intercept is at negative 5, 0, so I will label that as negative 5, 0 there. And my y-intercept is somewhere at 0, 4, so I'll label that as 0, 4. Just gonna move my, negative 5, 0 so that I can draw the line through it a little bit easier. And I have my 2 points, so I will connect them using a straight line. And I will label my equation as 4x minus 5y is equal to negative 20 over here. So for the sketch, what we're looking for is, obviously you want to have your x and y coordinate systems there. You want to label your equation. You want to have proper line with arrows. And you want to have 2 points over here, at least 2 points shown and labeled. So you need to have proper points, and you need to label them as well. For finding x-intercept and y-intercept, you need to show that you're solving for x-intercept by setting y is equal to 0. That's a method mark. Properly solving it, I will give an implied method mark for this one. There's no fractions, so there isn't much steps involved, and an accuracy mark over here. And on this side, you need to set x to equal to 0, a method mark here. Actually, I kind of want to see it in there. I don't want to give this as an implied. So let's erase these two and actually make it a solid method mark for plugging things in correctly and actually solving things. So there's at least one method mark here. There could be another implied method mark depending on the difficulty of things that you need to arrange, and you need to finally leave your final answer accuracy. If the question asks for the coordinate, then you want to put it in coordinate form. If it just asks for the x-intercept, you can leave it as x-intercept is -5. Actually, let's just leave it as the coordinate all the time. And yeah, so for the sketch, everything over there, make sure you label your equation, you have proper line with arrows, you have indicated your 2 points, and you have your x and y axes.